All right, hi guys. If you're in station number 3, conditional statements are not your best friend, but that's okay. We're going to fix it. Now, remember, with a conditional statement, it's an if-then statement, and you have the hypothesis, a conclusion, and you're going to be expected to go from your notes and be able to remember from your notes where the hypothesis and where the conclusion is located and how to work with those. So the first thing I'm going to do is I'm going to work the problems from the quiz over the conditionals. And I'm going to show you the right answers so you can fix yours. Then what I'm going to ask for you to do is to stop your video, and then, because it will be video 1, and then for part B, video number 2, or part B, I want you to, before you watch it, go ahead and work out these problems, and then use the video while I'm working out as a way to correct yourself. It's just a quick correction process, and it will help you know if you understand it or not. So let's go ahead and get started on this first one. Let's do the problems from the quiz. First of all, a converse is a conditional form by negating both the hypothesis and conclusion of another conditional. And the problem is that that's a false. What that really should say would be inverse. Is a conditional form by negating both the hypothesis and conclusion of another conditional. Now, biconditional statements must be true. And the answer is yes, they have to be true or you cannot write them. Because it has to have the original conditional and the converse are both true. So the conditional and converse both have to be true. So that's the definition of a biconditional, an if and only if statement, formed only if they're both true. Now, you're supposed to underline the hypothesis and circle the conclusion. So in a basic if-then statement in this form, my hypothesis would be if you take your quiz and then your conclusion is, then you're not absent from class. Now, what if I change it up and I write conditionals in just slightly different wording, but they're still conditional, like this one? The measure of angle 1 equals the measure of angle 2 implies angle 1 and angle 2 are congruent angles. Implies replaces the then. So really, my hypothesis is the measure of angle 1 equals the measure of angle 2, and my conclusion is angle 1 and angle 2 are congruent angles. Now, the next one says the sky is clear if there is no clouds. Now, this is one. It is still written as a conditional statement, but my hypothesis right now is there is no clouds. My conclusion was written first. The sky is clear. So because of this way it's worded, do not ever, when you're writing your converse, inverse, or contrapositive, don't you switch your if and thens around, because if you switch the if with your hypothesis, you just get the exact same conditional statement. Then the last one are, all odd numbers are not divisible by 2. So what is it? Odd numbers are what are going to be your hypothesis, and not divisible by 2 is going to be your conclusion. Now, on the next part, we're supposed to write the converse, inverse, and contrapositive if possible. Well, the converse, if you remember correctly, that is when you switch your hypothesis and conclusion around. So it would be something like this. If 2 lines are, and I'm going to abbreviate to save some time here, are perpendicular lines, then they intersect at right angles. All right? Now that's the converse. Now, I'm always going to go back to my original statement. If I'm doing the inverse, that means opposite. So I'll negate the hypothesis, then I'll negate the conclusion. So it would be the following. If 2 lines do not intersect at right angles, then they are not perpendicular lines. And that's very true. If they don't have that, it wouldn't work. So that's the inverse. Notice I didn't switch the hypothesis and conclusion, I just negated them. Then the contrapositive is when you switch and negate. So that's when you'll go, if not Q, then not P. All right? So that'd be the following. If 2 lines are not perpendicular lines, then they do not intersect at right angles. Again, and notice with this, I expect correct punctuation and grammar with this. All right. Now, the question is, can I write a biconditional? And the answer is, oh yes, because a biconditional is an if and only if statement formed if the converse and the conditional are both true. If two lines intersect at right angles, then they're perpendicular lines. That is true. If two lines are perpendicular lines, they intersect at right angles. That is also true. So I can write an if and only if statement then. So this is what I'd have. Two lines intersect at right angles if and only if they are perpendicular lines. Now, another way you could say it is like two lines are perpendicular lines if and only if two lines intersect at right angles. But notice where the if and only if is located. All right, now the last thing is you are going to have to know your past definitions. That's just kind of a huge thing that you need to know. So it says write the definition as a biconditional. Any good definition should be written as a biconditional, and this is one of those. What is the definition of an angle bisector? Well, let me put it this way. It is a ray is an angle bisector if and only if it divides an angle into two congruent angles, or divides it into two congruent parts, or something in that manner that lets me know that you have those. Okay, so I need you to stop and try the backside. And once you do that, I want you to watch the second video with how to do the corrections.